over here so I can hopefully keep track of things. And let me share my screen. All right, so hopefully you can all see my screen now. So for those of you who don't, all right, so let's get started. For those of you who don't know me, my name is Deborah Melkin. I'm really excited to be invited to talk to you today about optimized locking. It's about improving SQL Server transaction concurrency. This is a part of a multi-session learning pathway that we were able to present at Past Data Community Summit, this past summit, 2025. And so this is session 3 of 4. If you missed the first 2 with Jeffy Anucci and Harpreet Naidu, please make sure you go watch those, and then you can catch Andy Yoons, who's coming up next. I'm really excited about optimized locking. So for those of you who don't know me, my name, as I said, I'm Deborah Melkin. I've been working with the database platform for over 25 years now. I was 3 when I started. Don't do the math. I'm a data platform, Women in Tech virtual user group co-leader. I'm a co-founder of Witspiration, which is a women's mentorship circle. So if you're interested, ping me afterwards. I'd love to talk more about those. I'm a Redgate community ambassador. I'm also a Microsoft MVP for the data platform, which means I love geeking out over this stuff and sharing what I learned with all of you. I have a blog, Deb the DBA, if you're interested in that as well. In my spare time, I'm usually doing something musical or with my husband, Andy Yoon, and we're usually doing something geeky with our dog, Sebastian, who will definitely pop up throughout this presentation, like here. So he's here demonstrating the problem we're trying to solve, which is everyone's favorite, locking and blocking. This has been, since I've started working with SQL Server, this has been one of the biggest problems we've had to deal with. How do we deal with locking and blocking and moving past it? And all the concurrency that we have when everyone's trying to go after the same pieces of data, same rows on the same tables. So introducing optimized locking. This is pretty cool. It went GA in Azure SQL DB back in February 2023. So it's almost over 3 years now, right? But I feel like this is kind of one of those hidden things that is there, but I'm not sure if people realize it's there to take advantage of it. It is very cool. It is enabled by default. That's pretty awesome. Which also says why it's important that it's now in GA with SQL Server 2025. There's a lot of cool things with 2025. This is one of them. Make sure you pay attention to it. You do have to manually enable it by database, which, you know, it's something we're kind of used to, but it is manually enabled. It's about rights, not blocking rights. Let that sink in for a second. It's really cool and it's pretty powerful, especially when we have blockings and we have those highly concurrent transactions where everyone's doing a lot of writes against everything at the same time. So our goal today is we want to talk about how it worked. We're going to talk about the components used by it, starting with read committed snapshot isolation level. If you missed Harpreet's session, go back and watch it. She gives a great fundamentals to it. I'm going to go over some of the basics to make sure we're all caught up as well. Accelerated database recovery, ADR. If you don't know this feature, you should. We'll talk about why. We're going to do a review of lock escalation, and then we're going to talk about optimized locking itself. There are 2 main pieces to it, transaction ID locking and lock after qualification. So a couple warnings for you. We are going to get into internals here. We're going to get a little geeky, but it's really important to understand the details behind how this works. So I am going to just level set, make sure that you know we're going to go internals. We're going to call it level 300. By the way, I'm keeping an eye on chat for questions. If you have stuff, I'll try to do that. I may take a break larger between demos and the slides, or slides then demos, and we can take a look at there. There's already a question, is it on by default in 2025? No, not yet. It's not on by default. You do need to manually do it. But if you're in Azure SQL, it is. So let's also kind of make sure we understand pessimistic versus optimistic locking. Pessimistic is what we're kind of used to. That's kind of been the default mindset. So essentially it's, I don't trust you. I need to use this data. You need to use this data. I'm not sure that we can work together. So we're preventing others from modifying data from each other. So this is where we talk about read uncommitted, also no locks. We have read committed, serializable, and repeatable read. Most people are familiar with the first two, serializable and repeatable reads. If you know the use case for it, you know the use case for it. You have a very specific need for it. Versus optimistic locking. And this is kind of what we've been moving to. This is where I know you're going to be working with the data. I'm going to be working with the data. Maybe there's better ways for us to do this. So we're figuring out how not to lock data when reading data. But if you're modifying, then we can check to see, hey, is there modification? Is there ways around it? Or I can wait a little bit. So this is where we're talking about snapshot isolation, whether it's read committed snapshot isolation or just snapshot isolation. We'll talk a little bit about the differences between those two. And this is where optimized locking comes into play. And it's weird, optimistic locking, optimized locking. The wording is a little tricky, but optimized locking is, as you can guess, optimistic. So let's talk about more. Let's go into some of the details here. We're going to start with read committed snapshot isolation. This is the first thing that you want to understand. It was introduced way back in SQL Server 2005. I got to be honest, I don't think I learned about it till like 2017, 2018. But let me tell you how much dev in 2004 really wanted snapshot isolation. I didn't know it at the time, but I really did. It's where reads and writes don't block each other. And I think this is kind of the important thing. This is where if you're writing something and I need to read it, well, you've got it locked for that transaction. The data's in play. I just want the committed version of it. And so, or because I don't need to see your change, I just need to be able to read the data. So this helps us work around those sort of blocks. There are two database options for this, as I mentioned earlier. You have the set read committed snapshot isolation. This is where we're saying what's the default for the database. When I have a connection by default, what isolation am I using? So that's where it's saying read committed snapshot isolation. And then you have another option on the database, which is allow snapshot isolation level. So this is maybe you don't want it on by default. There are reasons for it. I'm not quite sure what those are. Maybe you're testing, you didn't realize you hadn't been using it, and you want to see the effects before you make it for everyone. What this does is it allows you to say for that particular batch or that particular query or proc or whatever it is, you want to set it on an individual level to say whether you want to use snapshot isolation or not. So it's a little tricky to understand. You don't need snapshot isolation to allow snapshot isolation to have read committed snapshot isolation. Again, it's kind of confusing. Most people will just say both in general, just so you don't have to worry about it. But understand that there's a small difference between the two. Just be aware of that. So how does this work? This is really what we care about more. So first, every row in the database is given a transaction ID. So now it does add a little bit of space to your database because you have to have a space for every row, but we now have a transaction ID so we can track who's making a change to that row. And then we keep copies of the previously committed version of the records in the version store in tempdb. Yes, this means you need to make sure you have space in tempdb to hold all of these different versions. And then when you go to read the data, you're only reading the committed version of that data, and you're reading it from tempdb, that version store. So this is where we're kind of saying we can have writes not blocking reads. So this way reads are only dealing with committed versions. We don't have to worry with the data in play. We can trust the data that's being written to. So what does this look like? All right, we have this example. Sebastian is moving to Massachusetts. So we need to update his customer record. So now we have an example. We have the updated record in the table here. We put a lock on the key for that row. And then when we have read committed snapshot isolation, we then take that copy and now we're writing it to the version store, which is in tempdb. A couple things I want to point out here. Notice this 1A. That's not what it actually looks like, but it kind of gives you an idea. It's more just to make sure you see what it looks like or something is there. This is your transaction ID. This says what transaction is modifying this row, which is cool. We can kind of keep track of these things now. The next thing you'll notice in Version Store is you have a transaction sequence number. Because, you know, transactions aren't always going to be one row at a time, or you have those long running transactions which do like, you know, 10 unnecessary updates of the same row. Okay, maybe they're not unnecessary. They usually are, but not always. But whatever it is, we now have a transaction sequence number, so we can keep track of that as well. So we see everything that's all the changes that are part of that transaction sequence. Now that we see what the data looks like in Version Store, along comes our select statement from a different SPID. So where are we reading from it? It's a different transaction. We're doing our select. Where's it going to go? It's going to read out of Version Store. And there you have it. I don't care about that begin tran. I don't care that it's still open. I can still see the data. I can see the previously committed version of my row, and I'm good to go. No blocks. It's great. Love it. All right. Now we're going to move to the next step, which is accelerated database recovery. I know it's weird that this kind of goes along with isolation levels because it's not really an isolation level. It was introduced in SQL Server 2019. It is the default for Azure SQL database, and it cannot be turned off. Every now and then I like pointing these out because in some ways, if you think of like Microsoft and Azure SQL, and some of the settings that they have, it's like Microsoft is the DBA, and the DBA for these by default sets this on and doesn't allow you to turn it off. Every now and then I kind of watch this to say, I may want to pay attention to that. Accelerated database recovery is one of those things. It is huge. And actually, they just announced this morning the 8 KB lineup in August. And I think John Morehouse's session on this is going to be there. I'd be recommending it anyway. Go look it up. Go watch it 8 KB. I believe it's in August sometime. Go watch it. Whatever it is, watch it. Accelerated database recovery is really cool, even if it had nothing to do with optimized locking. Why? Because it changes the way the transaction logs are read. So it's able to recover from long-running transactions much faster or just restore things faster. I can't get into the details. I'm going to explain it horribly, but it has to do with the way it does the redo logs and figuring out what the transactions in motion are. So it doesn't have to read through everything in the logs that are stored when you have those long-running transactions. It's really cool. Those transactions that have been running 7 hours that you can't kill because it'll take another 10. Now it's almost instant. It's really cool. You want this feature. The other reason you want it is because it uses a persistent version store in the database, the user database, rather than version store in TempDB. So for those of you who have RCSI on and TempDB just gets hammered and you're just all the contention and all the space that TempDB needs, this may be a solution for you because now we're taking that space out of TempDB and the contention out of TempDB and moving it to our user database. This is really cool. So what does this look like? So we're going to go back to that select statement that we were talking about earlier, our update. We see it in the table, we lock the key, we have our transaction ID. So even if you don't have RCSI turned on, but you do have accelerated database recovery on, you will still have a transaction ID added to each row. So now we need to go make a copy of that previously committed version. Version store in TempDB? Nope. It's going to our persistent version store in our user database. So now when we have our select statement coming in from a different session and it goes to read, it's going to read from the persistent version store. So it's the same concept. It's just where we're reading from is different. It's not for TempDB, it's now our user database. So this is pretty overly simplified, but hopefully it makes sense. Now we're going to take a quick break from talking about where we're reading the previously committed versions from and talk a little bit about lock escalation. And in some ways, I feel like we haven't talked about lock escalation in a long time. Snapshot isolation does a lot to kind of avoid, the blocking, so we're not thinking about locks, but lock escalation is still in play. So what is it as a refresher? It's that threshold at which SQL Server says, I've got too many low-level locks. I can't deal with all of this in my memory. I need to handle this better. So I'm going to upgrade those lock or move to a higher level locking situation so I can manage my locks easier. These are the documented thresholds. But I say the word documented because there could be cases where maybe it's a lower level lock that cause or lower number that could cause escalation. But these are kind of what to think about. And these numbers are the number of locks, not the number of rows, because you may have more than one lock taken out per row of data that you're using. It's a little confusing. Bob Ward has a lot of demonstrations around optimized locking, and definitely spend time looking at those. But some of those, we can see the lock escalation at 2,500 rows, not even close to this 5,000 locks that we're seeing here. So just so you kind of understand that there is a difference. So the threshold at which SQL Server will convert lower granularity locks is 5,000 on a table or index for a single statement. Now we've talked about log running transactions, begin transaction. When you have that, it holds all the locks until you hit that commit or rollback. So every 1250 locks taken in that transaction could also SQL Server do a check and say, hey, do I need to escalate my locks? So it looks from there. So this is kind of important to understand where this occurs. The granularity, this is taken from Microsoft's documentation. I've kind of formatted to make it a little prettier. Most of us are familiar with the row identifier lock or a key lock. You know, we've heard of page extent locks and table locks. It's really those row, key, and tables that we usually see. We can kind of see intents per page, but we can see where this sort of locking is. What happens is, this is an important thing for lock escalation, we don't realize it. When you have a row or key level lock and SQL Server needs to escalate, it goes straight to table, not to page. And by the way, this lock escalation is why that read uncommitted or no lock can lie to you, where it's no shared locks, right? So some of those lower levels, but sometimes it's doing stuff and it still needs to escalate. This is why you can still get deadlocks and blocking even with no lock or read uncommitted. Ask me how I know. I've had that since the earliest versions of SQL Server, and it's still true today. But we need to remember that row and key go directly to table. It does not stop go at page or extents. So that's an important thing. There's also a great article from Eric Darling, a great blog post called "The Query Decides the Isolation Levels." This one's a lot of fun too, where it's because of lock escalation. And when you think about it, whatever your query is, these lock isolation levels, sometimes the no lock, it's a hint. Sometimes SQL Server has to ignore your hints just because it needs the resources it needs to deal with a query and get the data. It can't abide by that hint. It says, thank you, but if I don't do shared locks, I'm just going to need to escalate and we'll go from there. Or there may be things under the cover that it has to do. Or it's the isolation level you set, it may need to do something higher. It may need to do locks differently. It's a great blog post. I love it. Please, I've got it in my resource. Spend some time reading it. Hopefully you'll find it as kind of, I found it just really insightful and kind of changed the way I think about things or I want to explain things. So hopefully you'll find it too. And now we're getting to optimize locking. I see two quick questions. One, if this is a readable secondary. Readable secondaries, you're getting the locks. I'm optimized locking, because you're not writing it, or the logs are applied. I'm not sure that you're going to a version store at that point because you're only getting committed versions on a readable secondary. Double check that. Someone's asked me that before. I have to double check, but because readables secondaries are only committed transactions, you may not have to deal with a version store as much. And the question is, there overhead when you turn on ADR per database because of space usage? Yes. Yes, it's same with snapshot isolation, right? Because snapshot isolation, not only do you need to make sure you have room for the transaction ID, but you've got version store space in TempDB. When you have accelerated database recovery, yes, you need to have version store in your database So you need to make sure you have space for that persistent version store in your database versus in TempDB, but you also have the transaction ID. So yes, you definitely need more space, but you should know your workloads and you can plan for it accordingly. So now let's jump into optimized locking. It's changes to the locking mechanism. Now, for those of you who've been working for SQL Server for a while, I'm going to give you a quick second. Think about the last time they made a change to the locking mechanism. If you're racking your brain, it's because they haven't. This is really the first change that they've made for locking mechanisms. This is pretty significant. And it's one of those quiet things like, oh yeah, we've locking mechanism for the first time. Wait, what? Right? It's very cool and it's pretty important. And then thinking about all the way everything's kind of built on each other for that locking mechanism, this is pretty cool stuff. What it's doing is before we saw it lock on the key, and it had that lock on the key. Now what we're doing is we're going to take a lock on that transaction ID. So this means when we still have to take locks on the keys and on the rows to actually make the change, but we no longer need to hold it because we know the row that we're changing. We can say this is the transaction ID that made the change. So as long as that transaction ID is there, we can hold that lock and we don't need to lock the rest of the table, which is really cool. This is what we can do then is because releasing those locks, we've minimized lock escalation. Think about that. That's really cool. We do need accelerated database recovery to make this happen. That's the one thing. So yeah, you do need to make sure you have space for all the changes for the persistent version store within your user database. But it's also cool because all the benefits of accelerated database recovery you're getting here too, in addition to being able to use optimized locking. So let's look a little bit more about how this works. So now what we see is we have our same update statement we've been working with. We go to our table, we have our change here, we locked the key to make the change, but now we're taking a lock on that transaction ID. So now we have that lock while this transaction is running. We know what it is. We no longer need to hold on to that key because we've already made the change to the record. We've written a previous version of it. It's still getting written. We still have a copy of the previously committed version in the version store. So now we need to go select the data, and it's going to our persistent version store. Great, it works. But as Sebastian just pointed out, that's for our regular select statement. That's kind of what we saw with RCSI. It's what we saw with accelerated database recovery. I promised you writes not blocking writes. Where is that? So there are two things that make that happen. The two parts to it. First is this transaction ID locking. That's really how it works, right? We lock that transaction ID. So as long as that transaction ID is held, we can see sometimes when we do like a table lock, we had to escalate. Well, even though we needed all those locks, not all those rows are being updated. So now we can say, hey, does this row have a lock on it? Is there another transaction modifying this row? Oh, that row is clean. I can go update that row and grab the transaction ID for that row while transaction IDs are being held on other rows. So now nothing's being affected and we can update without waiting. Let's see what that looks like. So we have our first transaction that we've been working with. We had the lock on the key. Now we just have the lock on the transaction ID. Our persistent version store, we have the previously committed version of that row. So now what happens when our second transaction comes along? Now, I didn't grow up in Massachusetts. I'm moving to Massachusetts. So now we can see, this is what it looked like before. You see my row in the table. I grew up in Tennessee. Nothing's locking my row and I need to go change it. So now what can happen is we can lock the key, make the change. We have the second transaction ID. Now I've locked that transaction ID. I've made a copy of that second row to that persistent version store. And I'm able to make two changes to the table at the same time. Why? Because the row my second transaction needed wasn't the one that already being locked by the first transaction. So now we're really able to lock things on transaction levels, what rows are being affected. And I just had writes not blocking writes. That's pretty cool, right? All right, so now we have lock after qualification. This is a second piece to optimize locking. Now here's the key. RCSI is a requirement for this work. Transaction ID, you don't need it, you just need ADR. Now we need RCSI. This one's a little more complicated to understand, and once you get it, it's like, oh, that's pretty cool. So essentially, we look to see if the previous, so now we've got two transactions. The first one's being updated. Now we have a second transaction that comes along that needs that record. So now we have to say, okay, well, the record I need is being locked. Someone else is using it. Does the previously committed version of that row, is that qualified? Is that based on something my query would go update? Do I actually need that row? So now what it can do is it says, okay, the previous version, yeah, it meets. So let me wait for this transaction to be done, and then I can go see if I need to update that row still. And if so, I can go update it. If no, the transaction is going to say, oh, well, I didn't need that row anyway, so I'll just skip it and continue along my merry way. So let's see what that looks like. It's easier when you see it in action. So we have our transaction. So before Sebastian moved to Massachusetts, he did a stint in Georgia. Sebastian likes moving around. Who knew he is such a well-traveled puppy? So we need to go update that row. We see the row, we see it updated. We have the key locked, we have our transaction ID locked. The record's now in our persistent version store. Now we have a second row. It's saying, no, Sebastian's in Massachusetts. This is what it needs to be. So what happens? Well, our row is locked. All right, another transaction has it. So now what we have to do is say, would the previously version, what's in our persistent version store, match the criteria of my query? Is it going to be something that matches? Well, we're doing on first name, and well, yes, Sebastian matches. So therefore, I have to wait. It's qualified. So what am I waiting for? I'm waiting for this commit. And once this commit is done, this second transaction can say, oh, it's free. Does it still match? Yes, it does. I'm going to put them on my transaction. I'm going to make my change. And then I can write the previous version to the persistent version store and call it a day. That's pretty cool. So now we're able to wait. But again, everything's based on the previously committed version. And then once that's done, then we can reevaluate to see if it's done and if it's needed. There are a couple other improvements that come along with lock after qualification. I presented this like 2 days or 2 days after, I think 2 days after SQL Server 2025 went live. So I got to change it to talk about these two things that they talked about. This first one is really cool, the skip index locks. So when you saw my examples, you noticed that I would say we got the lock on the key as we got the lock for the transaction ID. Here, the engine is able to be a little bit smarter. It's saying, hey, does anything else have locks on it? Or is there any other queries that may need to lock the key to make changes at the same time that I'm doing it? It can look for things that are repeatable reads or serializable or other things that are going on. And it can say, oh, there's nothing else going on here. I don't even need to try to take a lock on the key. I can just go directly to my transaction ID and move along. So it's not even having to do some of those extra work to say, do I even need to lock the key? That's pretty cool. I'll show you that one later. I ran into it in my demos when this was still in public preview, and I didn't even realize it till this was announced. I'm like, oh, I think I can show this. It's actually really cool. I think y'all will like that. The other thing that's important, notice when I said we did the lock after qualification, we looked to see once that previously committed version was done, we still had to look at the new version to say if that record qualified before I made the change. Well, as you can imagine, when you have a pretty busy database and you have a lot of things that are trying to read that row and are trying to do all of those things all at once, there's some overhead, right? Because it's constantly having to, oh, we have a line of like 10 transactions. That's probably pretty slow. We have 10 transactions that all need that same record coming from different places. The first one goes, oh, we have 9 more queries having to double check to see, can I do this? Oh, that one's released. Okay, I got 8 more queries. And after a while, that's going to build up. That's a lot of work that the engine has to do. And as you can imagine, that can be problematic at a certain point. So with the whole Microsoft's do no harm, we have all of these feedback and these feedback persistence that we're trying to do. Some of this you'll see in the query store feedback tables. That goes along with like memory grant and some of those other optimizations. But at a certain point, the qualification process, because it's going to take too much time, and it has to restart every time every other transaction on needing that row is done. What it can do is say at a certain point, you know what, I'm stopping the feedback loop. Originally, when it was released for the SQL database, it would do it on the database level. It's like, you know, we're having too much of this. I'm just shutting it off for the entire database. Now it can be done on a query level. So, you know, this query, I'm just running into feedback loop. Just stop running it for this query because there's just too much. So it's one of those things that it's also one of those things you're definitely going to have to walk the behavior of all the concurrence, how everything updates for those writes blocking writes and how everything works over each other. You'll want to pay attention to that. But now because the way it's being done here, you're definitely going to want to watch, especially those highly transactional systems, all the writes occurring at once. You'll want to be careful of that. Well, we've got some examples, so you'll see LAQ and kind of understand what we mean by that. But it does mean at a certain point, it may get turned off just because the engine can't handle it and it's going to be too much overhead and it needs to stop just for better database health overall. All right. With that, we're about to go to demos. I'm doing a quick check. I see a question here. Wasn't the Sybase SQL Server version lock at the 8K page level locks later row level locks were added? Is that the lock mechanism mentioned? I'm not quite sure, Bill. I got to be honest. I just know that the way that the row locking, that's about the lock escalation. I don't know if the lock escalation, if it changed from A to row, maybe that could be part of it. That maybe that was a lock level. But remember, it's also whenever you took those locks on the tables and such, it was always on the overall system and overall, whether it's the row lock or the page lock. That's where the locking was. The lock really and because we introduced a new lock type, yeah, that was probably row level. Maybe it was 6.5. I kind of asked, and they said no. This is really the first change to the locking mechanism. My guess is because everything was still on the way that it locked all the rows, or even though it said it was a table lock and such, the fact that we're able to do just the transaction ID. That's really what the big change is. So maybe it was 6.5, but that's still a long way back to go. So over 30 years. So that's still a great memory if that's what it was. So props on that. But this is the first major one in a significant amount of time. All right, so with that, let's jump over to the demo so we can kind of see this in action. The first thing I want to kind of do is show the difference between version store and persistent version store. So I'm created this new database just so I can isolate everything that we can. So I'm going to look at a couple of things. I'm going to look at start at our user options. And just so I really go down to at the isolation level, this is the easiest way I can see. This tells me what my connection information is right now. And we can see that isolation is read committed. And then just so you can see what things are, my isolation states, let's just do it this query. I don't have, everything is by default. This was a brand new database I created in my 2025 instance. And now we're going to check our version store. That's empty. Now we have a persistent version store. There are two different tools, two different DMVs I'm using. One is the persistent version store, and then the other one is the version store stats. So even though I don't have ADR turned on or optimized, I still have persistent version store stats. Everything is 0. But right now I can still get that just because I happen to be on a version of SQL Server which has accelerated database recovery. So if you are on 2019, you should still be able to see stuff. There may be more information added with additional versions, but right now you would still be able to see this DMV. So now let's create some data for TempDB version store. I'm going to alter my database. and set it to snapshot on. I'm just going to go RCSI. I could do snapshot isolation level, but I'm just going to do, for time, just the recommitted snapshot. This is this isolation level. I didn't reconnect anything. I know some people like to, get rid of all the users and make this change, but you don't have to. The rollback immediately would kill all the other connections anyway. But you can see we're already recommitted snapshot. So let's go, and if I wanted to, I could show you what this is. For time, let's just kind of move along. So I'm going to create a transaction here. I like naming my transactions just because it's easier for me to find them later. So let's go ahead and let's run this. I'm going to update all my customers in California. That's 4,447 records that I've just updated. So now let's check both versions of my version store. We notice, well, first, this is just TempDB, I should point out. So I'm looking just for this database. So now we can see all the individual rows that we have in our version store. By the way, if you have a lot of transactions in that overused version store in TempDB, this is going to take a while. So be really careful and mindful of where you're running these queries for, just because it could be too much. But for this small example, it's really easy to see what's there. Notice this transaction sequence number, 1360. Keep this in mind. We can also see how much space is used by this database. This is a great query if you have a lot of databases on your instance and you want to know who's using the most space in your TempDB version store. Now we can look at the persistent version store, and we know there's nothing there because it's just our CSI. Here's some cool things we can do. We can now look at the late transactions and look at stats. So this is one, we're looking for the active transactions. We can see this is up and running. We have a transaction ID number here, 592861. Keep that one in mind. But now we can see that this is one of our active transactions. You can actually, there actually is one where you can look for the active transactions that are affecting version store, whether it's under a snapshot isolation or it's reading from that data. I don't think I have that one here yet, but right now what I'm going to do is that I mentioned persistent version store stats. We have access to that, right? Because we're in 2025 here, and we can see that information. And what I like about this is really cool. All this active transaction ID, 1360. You remember that number from our TempDB version store? We're able to do it here. And remember, our oldest active transaction, global ID. Recognize this number? It's the one we just saw. So from our active transactions. So we actually have a way to connect all of this stuff. This is really kind of cool. And the other thing I want to kind of note is notice that we have our oldest transaction ID and we have the active global ID. One of the really important things to remember with when we talk about RCSI, and this remains true for not just for the version store, but the persistent version store. None of these can be clean if there is anything, if there, it's a first in, first out for version store. And this goes for your persistent version store. And it's across the entire instance. And this is really key. Part of the reason is if you have a begin transaction and you have multiple statements, the engine doesn't know if you're going to do a cross database join. And if you're doing a cross database join, you need everything consistent across that to the point where that begin transaction started. That snapshot is at the begin transaction. So all those multiple statements, everything that's been changed since that begin occurred, we need to keep track of. So even if you began a transaction, someone else began a transaction, if their second transaction finishes before that first one, everything here still has to be there. And anything in that second transaction, we still have to change, because what if that first transaction needs to reference that data? It's a little confusion, but it is a first in, first out. So if you ever need to find what that longest global transaction ID is to figure out where things are, we can actually track those things down. So this is really where those long running transactions and version stores, whether it's persistent or in TempDB, super critical to pay attention to and make sure you find them and tell people, hey, you need to shorten your transaction. You need to make it run faster. Please go do that. This is why, because there is overhead of maintaining that. So we can see that. And so now we see everything looks good. And at this point, I can roll back that transaction. Now, one of the things to note is sometimes it can take a while for these version stores to clear out. It is an asynchronous cleaner. The other reason why it's really important to kind of keep our transactions in check, making sure that they're running only updating what they need to update. Because even if you update something to the same record, it's still considered an update in SQL Server's book. So it's going to have a record to the version store. So it can take a bit for it to clear out. Sometimes I don't remember how long it takes, but it definitely takes a bit, and it's asynchronous because those records are still sitting in my version store. Hopefully they'll clear out in just a moment, and it's just because everything's an asynchronous cleaner. I'm not going to disable for now, but I'm going to go ahead and turn on accelerated database recovery. And as you can see, nothing much has changed here, but we can then check our isolation levels and see that it's turned on. And even if I were to turn on optimized locking, everything you see now will be the same. I've got these demos available up in my GitHub, so you can test those later if you want. But now I'm going to start my second transaction, and I'm going to do the same update. Now I'm going to check both versions of the version store, nothing in tempDB. So the good news is that's now all cleared out. And now we can look at our persistent version store and, oh, wait a minute. I'm not sure what that was. Wait a minute, it's empty. But Deborah, you told me accelerated database recovery is on. Where it's persistent, where'd it go? Let's get to that in a moment. I'll show you where that happened. But we can, just to show you, we still have our open transaction. We know that we made changes. If I go to this next one, look at this is the persistent version store stats. I've got my oldest transaction ID, 1563. I have an oldest transaction that should have matched what we saw before. But let's look somewhere else. We've got changes. Where did they go? Well, for accelerated database, we can look at, I have a couple other stats, another DMV we can look at, which is the physical statistics of the database. So if I run this, we see our version change. Not only that, see this in-row version record count. So for accelerated database recovery, this is actually similar to the way Postgres works as well. It's not quite the same, but concept is where if the change is small enough and it can fit on the data page, those changes don't get written to a persistent version store, it gets written to the page itself. And we see that here, it's considered in row. So if I were to go back, let's go back here, and let's run that update again. Same transaction, because we can do that. We can now look at our persistent version store, and now we can see everything written. Why? Because we've made a large enough change that it no longer fits on the data page. It's now moved to our persistent version store. 1563, we saw that number earlier. So now we see that transaction ID. It's all linked up. It's all together. Here it is. And then if we go to that last query we showed again, the physical stat of the database tables, we can look, we see version row count is no longer in row. Whoops. We can go over here. We can now see off row. So we can see how many rows are written to our persistent version store. So it's kind of cool. We can track all of the stuff using those internal data. But that's not the cool stuff you want to see. The cool stuff you want to see has to do with data changes, right? So let's go skip over, and I'm going to use my auto dealership demo database. And I'm just going to go over here quickly and just to show you what the current state is. No RCSI, no ADR. We're starting from scratch. We could check for open transactions, but we're going to look for locks in a second so you can kind of see some of the cool stuff. This is going to be for our transaction ID locking. So I'm going to use some New Hampshire states. We're going to begin a transaction. We're going to update New Hampshire to set the first visit to be today. We've done just over 4,800 rows. That's how many we've updated. Now we're going to do something similar. We're going to go to our auto dealership demo. If you want, we can test select, writes, blocking, reads. We know that one. And now we're going to update our transaction. Obviously, it's blocked. It's what we expect. But let's take a quick look at our locks that we have going on. Oops. I'm using this query here, and we can see that we've got to wait on an intent lock. On an object means it's table, so we have our lock on our table, we have an intent on our table. This is a locking we know and love, right? We've seen this. This is our traditional locking. So I'm going to stop. I'm going to roll back my transaction. I'm going to go here. I'm going to, roll back my transaction here. And let's go turn on optimized locking. Oh, hey, look, I meant to do that because, accelerated database recovery isn't on. You have to turn on optimized locking first, or you have to turn on accelerated database recovery to turn on optimized locking. So let's do that. And so now we can go back here and we can do this. It's now set. Let's try this again, shall we? So update New Hampshire. And let's update Massachusetts, begin. Hey, by the way, the first time I started working on this, I had a problem. I couldn't get this to work. Why? Because I didn't have an index on my state field. So indexing still matters and you still need it to make all of this stuff work. But let's go back looking at our locks again. This looks very different, right? We still have an intent exclusive lock on our table. So we may need it, but we didn't need it. Why? Because we had that transaction ID lock. We see that here. That's what this resource type is. So we just had locks, updates, writes, not blocking writes because they didn't need the same records. That's super cool. How many of you can say, oh, I know where this will help me? Hopefully a lot of you will, just because I think that's just really cool. All right, I'm going to roll these back and let's move on to lock after qualification. So the first thing we're going to do here is I'm going to turn on read committed snapshot isolation because we need this to work. I could turn snapshot isolation on too, but you can kind of see that we don't really need it right now. So let's do a very simple one here. I'm going to look at my sales history and I'm looking at a very specific record. So we're going to try updating the same record. This is also why once you turn it on, you really want to watch what queries are and what they're doing and watch the results. I find fascinating. So our first query looks like everything is where it should be. So first thing is we're going to do two transactions. The first one, I'm going to set the date to be November 17th at 8 p.m. and I'm just going to subtract $1,000 off of the price. So we should know what the new price is. So we're leaving this open. We're going to go to the second one. It's similar to what we're doing. And you will notice blocking because we are trying to update the same row and you still need to have a key lock to update the record. So I'm running this, but I'm setting it to 9 p.m. and then I'm going to convert the sell price. So it's a round number, but I'm going to subtract another $1,000. So we notice this is blocked. So we're going to go back here. We're going to commit our transaction. And now I'm going to commit the second one. You see it now finished because the first one was free. So now let's see what the results are. So our new transaction date is, this is the 9 p.m. If we did the first update, it'd be 8 p.m., but it did the update too. So we can see that it waited for the first one, and now that one's easy to see that it did the second one. But take a look at this original price. It was 27,141,682 as the original price. Now notice the sell price, it's down $2,000 and all of the cents are gone. So it took that first committed value, the first change that we made, it honored that first change, and then it applied the update, because it was after qualification, it applied that change on the second committed value. And so now we have a different sell price. That's pretty cool. But you can understand why you want to pay attention to the order that things get updated and the way transactions are, just to make sure the data is consistent based on how everything's updated because of lock after qualification. I don't know how much of an issue it is. Obviously, it's been around for a couple of years, so it should be pretty consistent. But if you're not used to it and you're not paying attention, you do want to make sure that everything still works the way it should. I'm a DBA. Paranoia is kind of built into the job description, right? But let's kind of look at a couple other things where we're changing things to see if it's going to match. So we have two records here. We have, we're looking for Sebastian, as in Milk and Yoon, our dog, who for some reason going to move to California. And now we see all the other Sebastians that we have who happen to be in California. There are 8 of them. He's going to make number 9. So first we're going to update our record. Now we're going to a second one. And we're going to update all of those other Sebastians. Now notice, we know one is moving to California, but this update finished. What does that mean? It means that because Sebastian didn't qualify in the previously committed version, he doesn't qualify here as well. So let's take a look and show that. So first I got to commit my transaction. Now I'm going to commit this one, and then let's go ahead and let's look at all the Sebastians in California. Notice our Sebastian doesn't have an email. Why? Because he didn't qualify when that statement was started. So what happens if he would qualify afterwards? So let's take a look. All right, we can see he could qualify if we update all of the, we're going to move Sebastian to Massachusetts. So now we can go here, and now we can update all the Sebastians in California. Now notice we have a wait. Why? Because there's a previously committed version that qualified. So what happens? Yikes.
Hey, Deb, 5 minutes.
Yes, thank you. All right, so we've committed here. So let's run this. And now we see all the Sebastians, but if we go down to this last one, because he no longer qualified after the transaction was finished, he's not there. The other thing I want to show you, try to show you quickly, is lock escalation. And this is what we see normally. This is kind of cool to see all of these things. Let's see how quickly I can show this to you. We can see, you know how I mentioned that it's not always one lock per row. This is all, you can see the examples in the demo, but what we can see here is this is just our regular update statement. We can see lock escalation here, where we had all the keys. This is for 8 records being updated, the Sebastians in California. And we can see all the key locks here. And if we go to here, let's go here. We can see we had lock escalation. So we could see we had a table lock here. Now, if I run the same thing for lock escalation, I'm going to kind of, because we've got less time, I'm just going to jump to the cool one. And this is optimize locking with RCSI. First of all, this first record, I had 5,000 rows, almost 5,900 rows returned for lock escalations. With the optimize locking with RCSI, we have 4,800, so 1,000 rows less. But I also want to show you something here. You can kind of already start seeing it. This is where we can see the skip index locking. So we had 8 rows, nothing else was going on. While it got the intent, it just took out one transaction ID lock. In one of the other ones, I have the step in between where you can see the locks being acquired and released. Here, it doesn't even need to do that. It just says, I just need my transaction ID and we're good to go. Now, if we continue and we look at some of the other things, we can see lock acquired. This is for the update for New Hampshire, where we had over 4,000, just under 5,000 rows. Look, we're acquiring just those intent for the page locks. but we only have that one transaction ID when we go to release it. So we could skip all of the, I think I need this, oh wait, I'm done, and release. It didn't need to do all of those steps, so it's much easier for lock escalation. Again, these are all available on my GitHub, and you can go take a look at those. And I see there's a request for the link for the GitHub. We're gonna come up to that very shortly. So let's kind of wrap this up so we can get to that point. There are a couple of things you can kind of guess you'll want to be aware of. One, that persistent version store, we already talked about it. You want to make sure there's enough space available, because when it's full, you can still read, but you can't do any more writes because it can't write there. It's much better than like tempdb, where tempdb causes the entire instance to fail over. Here, you're just hit with that one database. It's an asynchronous cleaner, so it could take a while for that version store to clean out. And the data remains until it's no longer deleted. And there are no more open transactions in front of it anywhere in the database or in that instance that could still possibly need that data. That last one is kind of the key, and that one's also kind of a game changer for me when thinking about transactions. And obviously, keep your transactions fast, tune your queries. Lock after qualification, we kind of mentioned this. Blocking and waits can still occur. That's okay because we understand why it's happening. So you do want to be aware of all those transactions that are updating the same pieces of data on the same records from different places. So you just kind of want to watch that, make sure everything's still updating and accurate at the end. We talked about the feedback persistence. Too much, it's going to stop. So with that, that's a quick recap. Hopefully, RCSI, ADR, you understand how those are being used for optimized locking. Definitely spend more time looking at other sessions for those. Harapriya just did a great one on RCSI. We know some great ones by John Morehouse are coming up for ADR. He's my kind of go-to person for ADR. I know other people are talking about it, but I like the way John does it. And I used it a lot for putting this together. Minimized blocking. It's minimized, doesn't solve everything, but it's still minimized, which is great. We've reduced the number of locks being held and the length they're being held for, which means lock escalation, again, minimized. It's amazing. And we have writes that aren't blocking reads or other writes. It's kind of mind-blowing and kind of a game changer. I have a lot of resources. Spend time with Microsoft documentation. I spend a lot of times with the transaction locking and row versioning guide. Spend a lot of time there. Bob Ward's GitHub, I mentioned that one. I saw someone posted a link to Eric Darling's article. I really liked it. Accelerated database recovery. I've got a couple other ones mentioned here. Again, spend time with documentations, go watch the sessions. If you want to geek out, there's a great white paper that really talks about this time recovery in Azure SQL databases. Spend time with that as well. GitHub, where can you find this? I think I need to add small updates, but most of this should be available to you. My GitHub is Deb the DBA, so you can go there. That's my blog as well. And you can reach out to me. I'm on Blue Sky, DG Melkin. That's also my Gmail. But let's see if there are any other questions. Yes, you will have the slides. You can get those other information. But first, I want to say thank you all for coming. Hopefully, this has kind of said, I need to spend more time with optimized locking. I do think it's a game changer and really important to understand versioning in SQL Server. So I'll open it to questions. Any questions that I missed?
Can I start, Deb? I have a question.
Yes, please.
Sure. So because I have the unmute button also.
Excellent.
Can I stop the recording? Theo, should I stop the recording or should I let it continue? Okay, I'm just going to stop it anyway.
I'm sure.
Oh, okay, because sometimes we just let the questions get answered on the recording too. So